if you are moving up the plane, if you are moving up the ramp, that means you are moving forward and you are moving upward as well. So you are moving in two directions by just moving along the ramp. So that means this vector has its components along x and y. So it has two components. By the end of this video, you will be able to learn how we can resolve a vector into its components. So without wasting any time, let's get into it. First, let me talk about resultant vector. A resultant vector is a vector. For example, if me is pushing this box with 10 newtons of force in east direction, and I call my friend to push this box alongside me, and she is applying, let's say, 5 newton force in east direction. So we are able to move this box. But what if I hire somebody to move this box who can apply 15 newton force in east direction to move this box? That means instead of two people doing this job, only one person can do this. So that means that person is the resultant of me and my friend. If one vector can do the job for two or more vectors, that one vector is called resultant vector of all those vectors. So now we have here combined all the forces into one vector, which is a resultant vector. But in here, in this video, we will talk about how we can resolve one vector into its components, but specifically how many components, because there can be any number of components of a vector. For example, if that box requires 15 newtons of force to push it into the east direction, I can hire 15 of such person that can apply 1 newton each force. So I will require 15% to apply 15 newtons of force to push this box. Similarly, I can hire as many number of person to do this job. So any component can have any number, any resultant vector can have any number of components. But we have a system of axes in x, y, and z. So that vector in x, y, and z can only have 3 rectangular components. If that vector is in 3 dimension, if that vector is in 2 dimension, that vector can have only 2 rectangular components. So maximum number of components can a vector have is 3 if it's in 3 dimension, and if it's in 2 dimension, the maximum number of components, specifically rectangular components, it can have is 2. So let's study how do we resolve a vector into its components. Let's study about x and y for now, and then we can generalize that vector into its 3 components. So let's say this is my vector A. I want to resolve this vector into 2 components, x and y. So what I'm going to do is take the projection of this vector on x-axis and take the projection of this vector on y-axis. So this is called ax, the projection of that vector on x-axis, and on y-axis it's called ay. So ax and ay are the components of a vector in x and y direction. Right? Now we have to find out the value of ax and ay. Let's say this vector is making an angle theta from the positive x-axis. So this is a right angle triangle. So in right angle triangle, we can write sine theta and cosine theta. So in this triangle, let's say OPB, in triangle OPB, I can write my cos theta as adjacent over hypotenuse. My adjacent here is AX and hypotenuse is the length of the A vector, because this is my hypotenuse. So this is a vector A and the length of that vector is the hypotenuse. So the length of that vector is this magnitude, and I'm gonna write this magnitude as just A only. So that would be A. So if I find AX from here, that would be A cosine theta. So I have found one component of A along X, which is AX, which is A cosine theta. Similarly, if in the same triangle, this is AY, right? This is also AY, same length. So in the same triangle, if I write sine theta, that would be opposite over hypotenuse, and the opposite is AY, hypotenuse is A. From here I can find AY is A sine theta. So I have found AX and AY, which I needed to found because AX and AY are the components of A vector along X and Y direction. But this is the magnitude of the component along X and Y. In order to define a vector, I need its magnitude and direction both, but I only have magnitude. So let's find out the direction as well. In X direction, the unit vector, which has magnitude 1 and along the X direction, is called I cap. Similarly, in Y direction, the unit 1 vector with direction along Y is called J cap. So in X direction, unit vector is I cap. In Y direction, unit vector is J cap. And similarly, in Z direction, the unit vector is K cap. So if I have to write a vector in terms of its components, that would be AX, I cap, magnitude and direction, AY, J cap, and we have found AX as A cosine theta, I cap, and A sine theta, J cap. That would be my vector in 2D. If I have to write that vector in 3D, I will write AX, I cap, plus AY, J cap, plus AZ, K cap. So this is my vector. So what's the magnitude of this vector? If I have to find the magnitude of this vector, this whole vector, that would be square root of X component square plus Y component square plus Z component square. And if I have to find the direction that we have found in first video in the previous lecture, that would be A vector divided by its magnitude, and that would be AX I cap plus AY J cap plus AZ K cap over its magnitude, that is AX squared plus AY squared plus AZ squared. That's the direction of A vector in 3 dimensions. So you don't really have to always form a right angle triangle. What I'm saying is, if this is a vector in 2 dimension, my A vector, and this is angle theta, this adjacent to angle theta would be always be cosine theta, and the opposite component would always be sine theta. So let's say, for example, if this is the vector B and it is making an angle theta here, so the component adjacent to theta would be cosine theta and opposite would be sine theta, and this is always true. You don't have to draw a right angle triangle always. So this is it for this video. I'll see you guys in the next one.